So when you talk about the higher level part of the transformation function, that basically has also the standard level fragment. The most important part is the basic functions. So let's say if you've got f of x, the general reasoning for f of x plus a functions, f of x minus a, f of x minus a in bracket, f of x plus a in bracket, negative f of x, f of minus x. Then you get is, let's say, f of ax and af of x. Um, so these are some of the basic things that you got to understand. Now, here, this one is obviously we know that it's the graph moves up by a units. This one is where graph moves down by a units. This one is to the right by a units. This one is to the left by a units. This one is reflection in x-axis, reflection in x-axis. This one is reflection in y-axis. This is the horizontal stretch factor by 1 by a, and this one is the vertical stretch factor by a. So I'll just take one example for each of them quickly. Now, for example, my function is f of x graph has been given here as, um, let's say this is something like this. There's a quadratic. Now let's say 0 comma, let's say 5 here. Now I wanted to just draw, let's say this point is at -1. So if I wanted to just draw, let's say the graph of f of x plus 2. So you're just going to move the entire graph 2 units up. So an identical shape is something like here you'll get. That's your 2 units up. So this point is going to be 1, and the rest of the property of the graph remain the same. Similarly, f of x minus 2, it moves the graph 2 units down here. So it'll be just like, it becomes something like this at when you move down. So that's your basic transformation here. Now, if it is f of x minus a, now f of x minus a simply means that, let's say it's something, if it is f of x minus 2, what does it mean is that it basically moves the graph, let's say 2 units to the right. So when it moves 2 units to the right, what happens is the shape of the graph remains the same. So something like here you'll get, this is the f of x minus 2. So that's this part of the uh, uh, graph. Now the next up is, let's say, reflections that I can clearly say is here. If it is negative of x, negative of x is reflection x-axis. So the graph gets reflected like this. F of minus x is reflection y-axis. Um, so f of minus x is reflection across y-axis. So it'll be something like this here. So this is the f of minus x graph. Now, most important is that what is expected at the higher level is that you should be able to translate these in form of language. Like I'll just come to that part a little later, but just quickly just talking about horizontal stretch factors. If you're drawing the graph f of 2x, so it means that you stretch the graph horizontally by 1/2. So what does it mean is that you basically compress the graph by a factor of half. So this point is 5, so to become 2.5. And this is 0, so the 0 remains at 0 itself. So the graph basically becomes more compressed like this. So this is the new quadratic graph that we get. Of course, this y values are invariant, so y is not going to change. The x value just get divided by 2. So this is the basic transformation skills. Now let's just talk about a simple equation. If I give a simple equation as f of x is 3x over x minus 1, or let's say I'll just first take is 3 over x minus 1. Now, first question that can be asked is that, okay, what transformation map 1 over x onto this graph? Now, 1 over x onto this graph when you see. So most important part is that, okay, this is the vertical stretch. Now, if it is that format, af of x. So if I make a vertical stretch factor by, let's say, 3, I get 3 over x times, 3 over x graph. Now then move the entire graph 1 unit to the right. So if I move the entire graph 1 unit to the right, right means I'm using this transformation. So if I move the graph by 1 unit to the right, it's as good as saying translation vector 1, 0. That gives me the answer here. So this is the basics example that I have given. Now let's take a little complicated one. So for example, if I've got f of x is negative 4 over x minus 1 minus 7. So when you do this here, now the transformation that we got is the first one is the reflection in x-axis. So my question is that I want to map 1 upon x to this graph. So first thing what I'm going to do is reflect in x-axis. So I get x-axis or y-axis here. So you'll get negative of x. So I get negative 1 over x. Now, you vertical stretch factor by 4. So vertical stretch factor by 4, and then move the graph 1 unit to the right. So if I move the graph 1 unit to the right by translation vector 1, 0, so you get negative 4 over uh, basically x minus 1. And this negative 7 moves the graph further down by 7 units. So this is where you basically get a general idea about the function transformations. Now let's just take some more challenging questions basically. So now let's say if I have got a function like here, let's say f of x is given to us, and I want to transform the graph f of 2x plus 3 negative f of 2x plus 3 minus 2. So what transformations basically, let's say, map the function, this function, under this one. So the first thing that what you do is that you reflect in x-axis, you reflect in x-axis. So reflect the graph in x-axis, and so you get negative of x. Then you do you be extra careful here. So it's there are multiple ways you could get these transformations, but here what you do is I prefer to make this first two common so that you get exact idea how much movement to the left or right here is happening. So after this, I do is the horizontal stretch factor by 1/2, and then move 3 by 2 units to the left, and then move 2 units down. So the general mistake that students make is that, okay, they'll say horizontal stretch factor by half, and then they move 3 units to the left. So rather than 3 units to the left here, actually it's 3 over 2 units to the left. So that's the mistake that generally happen. So just be careful. Now, for example, if I've got sine x graph, I've got sine x function, and I've got, let's say, sine 3x plus 5 function. Now I want to just find out what transformation map this graph onto this. Now in this case, the one which is simply coming is that, okay, you'll have horizontal stretch factor by 1/3, and move 5 units to the left. This is the one which is coming directly, which is wrong. So what you do is actually here, if you're doing the horizontal stretch first, so it is sine of, let's say, 3, you take common. So there's x plus 5 over 3. Now what you get is it's a horizontal stretch factor by 1/3, 1/3, but it moved by negative 5 by 3 units to the left. So move negative 5 by 3 instead of 5 units to the left. So that's the first part that we have here. So now this part, which is majorly for HL students. So let's say what we have is that, for example, if I've got, let's say, f of x is 3x plus 2 over x minus 5. And this is a very common question that is asked in IB. Now that, okay, what transformation map this 1 over x function onto this? So it doesn't seem like, okay, it is like 1 over x transformation. It seems like, okay, there is some complicated function. But what I actually do is, if I make some adjustments in this equation, if you clearly see, if I just do this, x minus 5 plus 5 plus 2. So what I'm just trying to do is, I'm just trying to get rid of this x minus x term from the numerator. So I just subtracted 5 and added 5. Now what I'll do is, I'm just going to retain like this. So 3 5s are 15 and plus 2. So here I added and subtracted the same number, so it doesn't make a difference here. So x minus 5. So it'll become 3 times x minus 5 plus 17 over x minus 5. So this becomes 3 plus 17 over x minus 5. In case if you didn't understand this part, you could simply just do the long division. So let's say 3x plus 2. I got x minus 5 as a divider. So you can take 3 here. So 3x minus 15. You subtract, the signs change. So it becomes 17. So when you have 3x plus 2 over x minus 5, this can be written as quotient plus remainder over divider. So that's the general form. So this is what I have got from both the methods. So any one method you could choose. Now, coming back to the transformation description. So if I take 1 over x function and I want to say, okay, what transformation maps? The first thing that I'm going to do is that, okay, vertical stretch factor by 17. That gives me 17 over x function. Move 5 units to the right, so it'll be 17 over x minus 5, and then move 3 units up. So the translation vector is actually 5 and 3 here. So it helps us actually, like, you can solve this entire complicated question, like maybe 6 to 7 mark question just within a go if you understand this logic. So this is also, it sometimes it can be asked even for standard level with the guided instructions, like they'll give you sometimes, okay, write this in this form, a plus b over x minus 5 form, then find a and b, and then do the stuff. I'll just actually quickly show you with this logic also, that in this case what you can do is that, okay, if this asks you to write in this format, you're just going to take LCM here. So you take LCM as ax minus 5a plus b over x minus 5. And if you compare the value of a here, this should be 3. So that should be 3 here. So a is straight away 3. And then constant term is 2 here, positive 2. So this should be, basically, this should be positive 2. So negative 5a plus b should be equals to positive 2. So you take negative 15 plus b is 2. So b is basically 17. So what we get is that the other alternate way to do for standard level in case if it's a guided question. So this is how you do the basic transformations. And let's take one more example on this now. So other question comes is where it involves the perfect square conversion. So let's say if you got f of x is something like 3x squared minus 6x plus 8, and they ask us that, okay, what transformation from, let's say I'll take negative here just to make it a little complicated. So what transformation map x square function onto this given function? So how do we do this kind of question in this context? So what we do is actually first you convert this into perfect square format. So just to convert to perfect square format, you make sure the coefficient of x squared is 1. So coefficient of x squared is 1. And then you take the coefficient of x, divide by 2, square that, add, subtract, and you get the first three terms. The first three terms also very clearly here as, let's say, negative, if I take x squared here, plus basically 2x. And you could take, actually from entire thing, you could take 8 out. I mean, from entire thing, you could take negative 3 out. So that becomes negative 8 over 3, but you could just keep it like here and keep plus 8 as it is. So the first step is there, that coefficient of x squared is 1 now. Be careful about the signs when you take factors common. Now the next step is that, okay, divide the coefficient of x by 2. So if I take negative 3, divide the coefficient of x by 2, so that's 1, square and add. So if I have got that, you square that. So 1 square is 1, add and subtract 1, and positive 8. So what we get is negative 3. Now these first three terms actually are x plus 1 the whole square, and then minus 1 as it is, and plus 8. So this part, what we get is negative 3 x plus 1 the whole square, positive 3, and because I'm opening up the bracket here, positive 3 plus 8 here. So we get negative 3 x plus 1 the whole square plus 11. So this is my perfect square form describing the exact transformation now. So for what transformation actually map x square onto this? So the first thing what you do is reflect an x-axis that gives you negative x square, and VSF by 3 you can do. VSF by 3 is a negative 3x squared. Then you move 1 units to the left, so negative 3x plus 1 the whole square. And then move 11 units up. So this is how you basically get from this function, you get this basic function. So this is how you do the general transformations.